All right, we are going to go ahead and verify the following trig identities. And remember, when you are verifying, you are only working with one side of the equation. You leave the other side alone. Always try and pick the side that's a little bit more complicated. So in this case, looks like the cosine theta tangent theta is a little bit more complicated. It's got more going on. Typically, what I will try and do is write them in terms of sine and cosine. So cosine, I'm going to leave that alone. Tangent is sine over cosine, and that equals sine theta. Well, I can put that cosine over 1. They cancel out, and I'm left with sine theta equals sine theta. They equal each other. I just verified it. Let's go on to number 17. So on 17, I've got cosecant squared theta times tangent squared theta equals secant squared. Well, I'm going to start with my cosecant squared side because it's more complicated. Cosecant can be rewritten as 1 over sine, and because it's squared, the sine is squared. Tangent is sine over cosine, and because it's squared, this is squared. Sine squared over cosine squared. That's square. That's supposed to be a square there. It didn't come out very well. There you go. And that equals secant squared theta. Well, what happens? My sine squareds cancel, and I've got 1 over cosine squared theta equals secant squared theta. Well, 1 over cosine squared is secant, so secant squared theta equals secant squared theta. It has just been verified. Let's go on to number 18. So on 18, I've got sine times cosecant minus sine theta. I'm going to go ahead and we'll start by just putting everything in terms of sine and cosine. So I'm still going to have sine theta, and cosecant is 1 over sine. Now I'm going to distribute. Anything times its reciprocal is 1. I'm going to get 1 minus sine squared theta. And on this one, we're going to look at that Pythagorean identity. And I'm going to kind of do the shortcut on this one. If you took that Pythagorean identity and you subtracted sine over to both sides, you'd have 1 minus sine squared, and that would equal cosine squared. So I'm going to do just the shortcut of cosine squared equals cosine squared. All right, let's look at number 19. On 19, we have tangent squared, cosecant squared minus tangent squared. Again, I want to get everything in terms of sine and cosine. Tangent is sine squared over cosine squared. Cosecant is 1 over sine squared. And that will be tangent squared again is going to be, oops, you know what? I'm going to back up. I just realized there is an easier way to do this. And sometimes in the middle of a problem, you realize there is an easier way to do this. I realized that this has a greatest common factor, tangent squared. So if I factored out that tangent squared, I'm going to be left with cosecant squared theta minus 1 equals 1. Well, if I come back over here and look at my bottom Pythagorean identity, if I were to subtract 1 from both sides there, I'm going to be left with cotangent squared. So I'm going to have tangent squared theta times cotangent squared theta equals 1. Well, that's going to give me tangent squared. Cotangent is just 1 over tangent. Those tangents cancel out. 1 equals 1. All right, let's go ahead and do number 20. On 20, let's make that a little bigger. I've got 1 plus cotangent. That's my bottom identity right there, which is cosecant. I'm going to have secant squared over cosecant. Let's type that out correctly. And that's going to equal tangent squared x. Well, secant is 1 over cosine. Cosecant is 1 over sine. It's a fraction divided by a fraction. You multiply the reciprocal, and I would end up with sine squared x over cosine squared x equals tangent squared x, which is going to give me tangent squared x equals tangent squared x. All right, let's do our last one. All right, let's go ahead and start this one by putting everything in terms of sine and cosine. So cosine x over sine x. Secant is 1 over cosine. And tangent is sine over cosine. Well, I'm going to go ahead and debated whether or not to simplify the numerator first, but I think what I'm going to do is go ahead and, or I'm sorry, did I say numerator? I meant inside the parentheses. But I think what I'm going to do is go ahead and distribute. And what happens is those cosines are going to cancel out, and I'm going to get 1 over sine x. And that's going to be plus 1 because the cosine, cosine, sine, sine are going to cancel. And 1 over sine is the same thing as cosecant. just verified it. All right, enjoy.